Remember, I've uploaded a video like this before, so this is the question. Now I want to take my time to explain each step in the solution. If you want me to help you get your average titer value accurately without you doing any experiment, just chat me up, comment or chat me through my WhatsApp number is there. If you want me to help you with your table too, just chat me up. Now let's begin. I've made some assumptions which I've shown before, that here I'm using my average titer of 20 cm3. You can use your own, alright? But these solutions are just to show you how the questions that you have seen can be solved in chemistry practical. The first question asks us to calculate concentration of C in mole per dm cube. That is concentration of the base in mole per dm cube. Mole per dm cube is the unit of molar concentration. So, and you have already been given in the question values like Ca, molar concentration of A as 0.2. Then I have my Va chosen by me as in assumption, right? 20 cm cube, my Va is 20 cm cube. V, volume of base, which is Vc in this case, since C is base in the question, is 25 cm cube. How did I get the 25 cm cube? It's constant. Volume of base is always constant. Usually it's 25 cm cube, alright? Then Na is the number of moles of acid, which is 2. You get this from your equation of reaction. Check the equation of reaction in that question. You discover that the number that is at the back of HCl is 2. Nb is 1. Or I can say Nc as the case may be, alright? Since C is base, is 1. That is the number. 1 is no longer written. It's not written as a coefficient. So 1 is 1. It's not usually written there. So don't forget. Then that is the formula that you use. CAVA over CBVB is equals to Na over Nb. I'm using CC there or VC because there in the question they said C is the base. That is sodium tricarbonate 4 decahydrate. Alright. C is the base. So usually we use B. So CAVA over CBVB is equals to Na over Nb. Ca is the molar concentration of A in mole per dm cube. Va is volume of A, average titer, right? Na, number of moles of acid. Nb, number of moles of base. Cb, concentration of base in mole per dm cube. Vb, volume of base, which is always a constant, 25 cm cube. So if you input them into that formula, you will get your concentration of C in mole per dm cube. Then the second part says you should calculate concentration of C in gram per dm cube. Gram per dm cube stands for mass concentration, right? Mass concentration. If you look at the question, we are given 14.3 grams of C in 500 cm cube. Mass concentration always has to be in gram per dm cube, not in cm cube. And how do you convert to dm cube? You divide by 1000. So since I've been given a mass of 14.3 in 500 cm cube, but what I'm looking for is 100 cm cube, then if 14.3 is in 500, obviously I will have to double it to get the mass that will be in 1000. That's how I arrived at the 28.6. 14.3 is in 500, x is in 1000. I'll just cross multiply and make x the subject of the formula. I'll get my answer. It's very simple. So you know 1000 is 500 times 2. So it means I also have to multiply the 14.3 times 2 to get my mass concentration. Then number 3 question is asking for the molar mass. Which formula am I going to use? I will use that formula that says molar mass is equals to mass concentration over molar concentration. Since I'm dealing with B now, base, and you've already calculated the mass concentration just now to be 28.6. Then molar concentration you calculated initially was 0.08. If you bring them into that formula, it will now be 28.6 over 0.08. You will get your molar mass. That is the molar mass of B. And the last question says you should calculate the value of X, or they can also change it to say you should calculate the number of moles of water of crystallization. Do you get that? It's the same thing as X, number of water of crystallization. So to be able to get my moles of water of crystallization, remember that the molar mass you just calculated for sodium tricarbonate 4, right? That molar mass you just calculated is for everything. It's the molar mass of both the water and then the salt itself. You know, it's a hydrated salt, both the water and the salt itself. So, and you know that Na2CO3, if you calculate the molar mass, is 106. You know, sodium is 23, carbon is 12, oxygen is 16. I believe you already know that. It will be 106. Then water, X water. Water is 18 because hydrogen is 1 and I'm having 2 hydrogen here. That is 2 times 1. Oxygen is 16. So 2 plus 16 is 18. So water, molar mass of water is 18. Since I'm having X water, that's why I'm having 18X because 18 times X is 18X. So 106 plus 18X is equal to the molar mass of that compound. That's my base that I just calculated. All right, 358. So I will equate them. Molar mass is molar mass, right? So I will say 106 plus 18X is equals to 358. If I make 18X the subject, I'll have 18X is equal to 358 minus 106. 18X is equals to 252. So X is equals to 252 over 18. That's if I divide both sides by 18. X is equals to 252 divided by 18 to give me 14. So it means 14 is the number of moles of water in this case. Remember that I said that the question may not come exactly like this, but when you understand what I've just done here, it gives you an idea of what you are going to do. You will get your own VA and use to solve your question.